In this DeBacco University video, I'll provide you with some of the trends as well as the definition of electron affinity. All right, I'm sure the obvious question you have is, what is electron affinity? And this is the energy change when a neutral atom gains an electron to form a negative ion. It's the first electron affinity. We can see that example right here. Here we've got chlorine, we've got an electron. We're looking at basically the affinity or the attraction to gaining that electron. In this case, energy is released, and this would be an example of showing electron affinity. So how does this work across the periodic table? Well, across the period, generally becomes more negative. It increases in magnitude. Higher nuclear charge and smaller radius make it more favorable for an atom to attract an additional electron. If we think about that, chlorine and our halogens, more negative electron affinity than phosphorus. And we see that trend here. If we look at our halogens, fluorine, chlorine, bromine, iodine, all of these are of a very high electron affinity because they want to gain that. They're trying to have that electron be closer to them because they're just one away from filling that outermost electron shell. Now, as you go down a group or a family, generally this becomes less negative. It decreases in magnitude, essentially. The larger radius and shielding effects reduce the attraction for an additional electron. Fluorine has a more negative electron affinity than iodine. So looking here at what generally would be the lowest, generally be the highest. Again, electron affinity, how readily a neutral atom gains an electron there. So we can kind of see the general trends in that periodic table. Another kind of visual for this, there are some exceptions. For example, noble gases have positive or near zero electron affinities simply due to the stable electron configurations. So we typically ignore them. Other elements here, like nitrogen, they have their own little way of kind of being anomaly in this case. But again, if we're looking at the general trends, very high electron affinity for our halogens because they're one away from that octet, so they have a tendency to gain. And we see very low electronegativities for both our alkali metals and our alkaline earth metals. Hopefully this provides a little clarification on exactly what this is and its trend over the periodic table.